Because I said, what do we got? And then I was like, Dark Knight. It's Gordon. What do we got? Only me. Only one. All right. When is it appropriate to use a logistic regression? Yeah. Anytime the dependent variable is a 1, 0 variable, a dummy variable, that's when you use logistic regression. It can't be between 1 and 0. You can't have a dependent variable with values like 0.5 and use a logistic regression. It's got to be either 0 or 1 as the possible values that each observation can take on. So that is when you use logistic regression. Does that make sense? The dependent variable. So y. X can be whatever you want. But the dependent variable y is a dummy variable. That's when you use logistic regression. Calculate the odds ratio for the coefficient on x1 and interpret it. Because I love my interpretations. How do we do that? What's an odds ratio again?
Probability of something over the probability of the total amount that's possible, right?
Probability of something over the probability of not that something.
Right.
Okay. Yeah. So how do we get that? When we have logistic regression coefficients, there's a very easy way to calculate that odds ratio. It's on a slide that has growing Academy Award statues. Table. This thing's gonna run out of batteries while we're using it. It is E raised.
Negative z.
Not the negative z, but just the coefficient. So our coefficient on x1 is 3.198. So I'm doing e to the 3.198, and that gives me the odds ratio. Answer. Done. So that's what you do. Just e raised to the coefficient gives the odds ratio. What's the interpretation of that thing?
24.48% chance that.
Not quite. So odds ratio is probability of A over the probability of not A. We got 24. Yeah.
Is it 24.45 times more likely that it would happen?
Yeah, exactly. So if I had a 6-sided die that I threw, the probability, or I'm 5 times more likely to not get a 6 than to get a 6, right? There's 5 non-6s, there's 1 6. If I throw the dice, 5 times more likely to not get a 6 than a 6. I'm 24.5 times more likely to get a 1 as my dependent variable compared to a 0 if I get one more unit of x1. So one more x1 makes me 24.5 times more likely to get a 1 as the dependent variable than a 0. Does that make sense? So that's the interpretation. Cool?
You said to get a 1 for the dependent variable?
Yeah.
Okay.
Yeah. That's what A is in this case.
Right.
The probability of A is the probability of getting a 1 versus not a 1. 24.5 times more likely. Calculate the fitted value of y for an observation where x1 is 1, x2 is 3, and x3 is 0. How do I do that? This is again a logistic regression.
小明放这里好。
What's step one?
Multiply the coefficients by x1, x2, x3.
Yes. Multiply these coefficients by our values for x1, x2, x3. So that's what we're gonna do. So we've got 3.198 times 1 plus 0.319 times 3 plus negative 0.449 times 0. And then is that it?
Constant.
The
Constant.
constant. Always remember the constant. We must add the constant. So that gives us 5.703. That's step one. What do we call this? 5.703. What is that?
1.
Yeah, z. So now how do I get my fitted values? Logistic regression. E to the negative z is part of the equation. Almost.
No,
1 divided by 1 plus e to the negative z, which in this case is my previous answers. So I'm taking the 5.703, plugging it in right here, negative that thing, 1 over 1 plus e to the z, hitting enter gives me 0.9966751489, which means what? These are my fitted values, it's my predicted value for y, but we know it's a logistic regression. Y can either be 0 or 1, it can't be anything else. We're giving it something else, 0.996675. What does that mean? What does it tell us? I don't mean to. Yeah, exactly right. There's a 90, if you have a 1 for x1, and a 3 for x2, and a 0 for x3, there's a 99.7% chance that you have a 1 for the dependent variable, and a 0.3-ish% chance that you have a 0. Wicked, right? Just the coolest. Okay. Questions about any of that? Everybody's good with that?
Yeah.
Gonna move on.
I got some.
Question 4, calculate the autocorrelation for the data from GBR and AAR respectively. Said data.
Well, should be this.
Autocorrelation coefficient, how do we calculate that? Where do I find that in here? This is the best part about wearing glasses. I can't see anything at all, but it looks like I'm important. Anybody know autocorrelation coefficient? There it is. That's the equation. What does it mean? I think maybe on the slides I did T instead of I. But yeah, autocorrelation coefficient is trying to find a correlation between this year's GDP in the table, that's what we have GDP, this year's GDP and last year's GDP. And it says do it for both countries. Because in this table, I have 2 countries listed, GBR and AAR. Because GBR is like Great Britain, but then I didn't want to make like another country. I wanted it to be fictional. And so I came up with AAR. because GVR is a rearranging of my initials, and so I rearranged the initials in the name of the class. There you go. Anyway, in the same manner, in the same pattern. You do it like that. It is only me what think of that. It's funny, I do that, I can totally tell you this, because that's my strategy for a lot of my internet passwords, is to rearrange letters and then match them up also with numbers. It's very clever. You should do it. Everybody should do it. It's just very easy to remember that you rearrange the letters together and then they match certain numbers. You're welcome. It's an excellent password strategy. Alright, so I want to do autocorrelation for just GBR, just these here. So I need to do this process. This is a recipe, this equation. Your calculator, the oven that we're going to cook all these ingredients in. So I'm going to do that first by clearing my lists, because they contain other things we will do later. Alright, so I've cleared my lists, now I will edit them. I'm gonna put in this list the values for GDP for GBR, which are 50, 55, 57, 61, and 65. Now I need to lag the values, and unfortunately I can't put in a blank on the lists, so here's my little secret, here's the secret sauce in my recipe here. I'm going to need to know the average of my values to do this equation, because clearly the average is part of it. So I'm going to calculate that right now with second stat math average mean 3 of list 1 is 57.6. And so now I'm going to go back, and in list 2 I'm going to start with 57.6, and you'll see that that will conveniently cancel itself out and not be part of our calculations, which is what we want. And then now I need to lag the values of GDP, which means I need to put, now I'm in the second year, I'm in 2011, I need to put 2010's GDP in, so 50, and then 55, and then 57, and then 61, and that's it. Because now we have them all matched up. Autocorrelation is about finding a correlation between these two data sets. So is there a correlation between this year's GDP, that's list 1, and last year's GDP, that's list 2. And so the formula for that correlation is this thing right there, which is what I'm going to do. And I'm going to create 4 more lists to do this. First one is this list right here, taking this year's GDP and subtracting the average. So I'm going to take this year's GDP, list 1, subtract the average of 57.6, which I've calculated, and I'm going to put that into list 3. Boom. Then I need to do last year's GDP minus the average. So I'm going to do list 2 minus 57.6 and put that into list 4. Shazam. Now I need to multiply those two together, those two lists, right? That's these parentheses now list 3, and this is list 4. So into list 5 will go list 3 times list 4. And then into list 6, I need to do this year's GDP minus the average, that's in list 3 already, and square it. So I'm going to take list 3, square it, and put it in list 6. What a lovely recipe this is. And then it says take the sum of list 5 and divide it by the sum of list 6. Very well, I say to the recipe. Sum of list 5 divided by the sum of list 6 gives me an autocorrelation coefficient of 0.3387. Sure, yes. Correlation coefficients are difficult to interpret because it's hard to tell when magnitudes matter. But this is basically a correlation coefficient, so it should be between -1 and +1, it is. And it's, you know, a moderate correlation between this year and last year's GDP. Just to point out, the thing that I did there, where I put is this first value, the average. The reason that worked out is because when I subtracted the average, it became 0, and when I multiplied these, it was 0, and I'm only supposed to take the sum of these four numbers, and so it didn't matter that this one was 0, it still worked out correctly. So that is why I put the average here, when really it should just be blank, and we should not even be incorporating that observation into the calculation of the numerator, and that little strategy. Good, questions? Yeah.
Did you multiplied list 3 by list 4 and stored it in list 5, right?
Exactly right.
Okay, what'd you do after that?
Then I did list 3 squared to put it in list 6. And then I did sum of list 5 over sum of list 6. How about we do it again, but for AAR? Let's see, our whole process again. All right, I'm ready to do it.
You asked him exactly what I was gonna ask.
All right, so I cleared my lists again, and now I'm going to do AAR. So these 5 values. So I'm putting in 58, I'm putting in 61, 66, 69, and 74. Yeah. I mean, I can think of the ways to do the program, trying to automate this whole thing, but yeah. We'll actually look at it a little later. But then I'm going to get the average of list 1, because I will need it, 65.6. And that's what I'll start list 2 with. 65.6. And then I'll put in the lag values, so 58, 61, 66, and 69. And then I do my procedure again. I do list 1 minus 65.6 is my average into list 3. List 2 minus 65.6 into list 4. List 3 times list 4 into 5. List 3 squared into 6. And then sum of list 5 divided by the sum of list 6. Done. You guys did that quickly as well? So this one is slightly more correlated with its previous findings. This is the easy question. The next one's the hard one.
Do you know how he got some command?
I just figured out.
Good, good. Moving on.
Oh.
Okay.
What did you do, second list? So the second list.
So understand the next question, which the next question is, run a regression on the following model. GDP, this year's GDP, is being predicted by last year's GDP. So let's look at the data here. I guess I could have pointed that way. But here I've got kind of shifted, 2010 is this one. Here's all of our data. I want to predict this year's GDP with last year's GDP. So this year's GDP in 2010 is 50. What was last year's GDP? So the GDP for 2009? We don't know. So we cannot use this observation as in the dependent variable. But for 55, we can try to predict that with 50. We're going to try to predict 57 with 55, and so on. But then here, we don't want to predict 58 with 65 because those are two different countries. So starting here again, we're not going to include this as in our dependent variable. So when I'm constructing the dependent variables, it starts on the second year, 55, 57, 61, 65. And then once I get to the end of that country, I skip the first year for the next one, 61, 66, 67, 74. And then here, for X, I put those previous values. So the previous year's GDP here, 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 and then here, 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 for each country. So that is the difficult part about this. But once we acknowledge that, it's fairly easy to set up our matrices. So, in A, I have my dependent variable. I already entered it, sorry. But you can see it's the same as that Y. So it's an 8x1 because we admitted 2 of the 10 total years that we had. And I've got it all written out right there.
As one.
That makes sense? And then for X, we'll get to that part. I need to include the column of constant right there. Everybody gets a 1. And then my independent variable X is the previous year's GDP. So there, 50, 55%, and so on. So these are those lagged values. Does that make sense? So then what do I do to run the regression? Greatest formula of all time. X transpose X inverse X transpose Y. So I'm going to do that. X transpose X inverse, oops, almost, X transpose answer number 5. Got it? So, the next question, yeah,
What was your, like, matrices again? Like,
Yeah.
matrix A and B?
so there is A, that's my dependent variable Y.
Okay.
So that's this year's GDP is what that's supposed to represent. And then X represents, oops, last year's GDP relative to those 10, right?
You skip 2010, but on the second one, we add 2010.
Then we start with 2000. Yeah. So that's what I did there. The next question, run a regression for the following model. We're going to predict this year's GDP with which country it is. So, I can write that here. That here's GDP. I want to create a new variable called country. What value should that take on?
One and zero.
Ones and zeros, right? So basically, I've got these string variables right here. I need to encode them like you do in Stata. And I'll do it Stata style, where GBR is going to get the 1. So I guess I should match these up with this GDP. 1, 1, 1, 1, 1. And then AAR will get 0. It will be the omitted category. So I can do that with the full data set. I don't have to drop anything because I have a value for country for each observation. So I put those in matrix C, in my Y matrix, which is just all the values for GDP. Just entered in straight up all the way down. Just like, as is from the table. And then now I'm going to try to predict those using country as a variable. So I have put that into matrix D, which is here. So again, I still need my constant on the side, but now I have an indicator variable. The first 5 observations were country GBR, and the next 5 were AAR, so I've given GBR a 1 and AAR a 0. And now I can use that to predict. Any guesses what the coefficients will be? Should be mind-blowing. Get excited. So now I'm gonna run the regression by doing X transpose, oops. Wrong side, that's Y.
上面这上面哪个是 B0，哪个是 B1啊？
X transpose X inverse
那最上面那个哪个是 B0，哪个是 B1啊？
transpose. So I had those in D and C, D
两个
being X,
不认识啊。
C being Y. I run my regression, I
好吧
get D.
谢谢。好。
That's amazing. Those are the, it's the mean. So AAR was the category we left out. It had a 0, so it's multiplying that -8 by 0. And so if all I know is the country, then my best guess is the average for that country, which is what the constant is. And then if you're in GBR, you have a 1, so you multiply that by 8, you subtract 8 from that constant, gives us 57.6. That's the average for GBR. That, I don't know, I think that's illuminating about what indicator variables do when you have them as independent variables. They're just giving them each different constant.
So negative 8 is B1, huh?
Huh?
The negative 8 is B1 in the
Yeah.
answer.
Yeah,
Okay, thank you.
so that's what we're multiplying country by. Okay,
Wait, what's,
yeah,
oh, sorry, for that matrix, the indicator variables you made, was that for matrix C or D?
D.
D, so what was matrix C?
The dependent variable, so it was Y, which was just GDP, straight from the table. No adjustments. Okay. Now it wants me to use both. Predict GDP with last year's GDP and country, which means I'm gonna have to go back to the dropping the first year again, because I need to use the previous year's GDP. So I'm gonna go back to my matrix. Y is still the same, but I'm gonna edit my X matrix to include a third variable, which will indicate which country we are in. So which of these 8 observations was from GBR?
From 4.
The first 4. And the second 4 were from AAR, so there it is. I've created an indicator variable for which country it is. I've got my lagged values of GDP, previous year's values of GDP, my constant in the Y matrix, my values of this year's GDP. So I'm omitting the first year for each country. And then now I just run X transpose X inverse X transpose Y again. And those are the results of the regression. Isn't that great? Easy, very easy, extremely easy, the most easy.
So,
Yeah,
so you just edited matrix B and put indicator variables for GBR,
yeah,
and then ran the regular X transpose X.
yeah. Very cool. Isn't regression fun? Interpret and compare the results from the regressions in questions 4, 5, and 6. We should say 5, 6, and 7. So there they are. Interpret and compare. What do we got? Let's start with the first one. What does this stuff mean?
Oh, I don't know. That's a good question.
So I got a constant of 2.56. We've got a coefficient of 1.022. What does it mean? Yeah, we're taking the previous year's GDP, we're inflating it, we're adding 2.2% of it to itself, and then we're also adding the constant. So you can interpret it as kind of this growth rate, but yeah, that's, I don't know, that's like the innate growth rate of GDP. I don't know what you would interpret it as. But growth rate is fine, growth rate. But yeah, right? If last year's GDP value was 100, we're gonna multiply it by 1.022. So now we're gonna have 102.2, and so we've increased our GDP by that value. And then we have the constant, so then it's gonna go up by even more than that. 4% growth rate. If your base is 100. Good? Does that make sense? Okay. Oh, it turned on. What was the results for the next one? How do we interpret those? 65.6 and -8. We already did, by the way.
Oh, that like going from or AAR had a negative or like GDP points and
Other way, because AAR gets 65.6 plus 0 times -8. So what it's telling us is the average for AAR is 65.6. The average for GBR is 57.6, because they get the 1 times -8. Right? So just including that indicator variable by itself is just returning the averages, because we don't have any additional information other than the groups that they're in. So it's just giving us the average for the groups. When we include them both, what does that tell us? Constant of 3.18. So that's nice. I mean, that's pretty close to 0, right? And then for each additional dollar of GDP that we had last year, we're gonna have $1.013 this year. Ran that again. And then which country we're in has a very small effect. That we can see that the GDP in GBR is less than that of AAR at all those times, but that's really because they started with less. They're kind of growing at the same